My name is Kevin Funk. I'm working for KDAP, and today I'm presenting you the Declarative State Machine Framework, short DSM. Okay, first about me, a few bits. I'm working for KDAP since 2010. I'm a Qt developer for more than 7 years, and I'm a long-time contributor to KDE and other free and open source projects. My main contributions these days are doing patches to KDevelop and Gamma-Rated Qt introspection tool. Maybe you've seen that at the KDAP booth already. Yep, that's about me. So what is this talk about? This is the Declarative State Machine Framework. It provides a QML API for creating and executing state graphs. This is reusing the original Qt State Machine Framework. You may know it already. This particular framework will arrive with Qt for 4.5. It's already pushed and reviewed on Garrett, so it's in mainline. It's part of master. And all this was initially created by the Ford Motor Company, and the idea is from Brett Stottlemyre. You may know him from the Qt development mailing list. Okay, so what is this really about? Let's just take a simple example. So imagine you want to create an application that has a button, and each time you press on the button, the label of the button should change. You may want to do that as a state machine. So here we have the state chart of our application. There are basically 3 states, S1, S2, S3. And each time we click on the button, it will advance the state machine, and it will go from S1 to S2, from S2 to S3, and from S3 to S1 again. The initial state here is S1. Keep that in mind. That's how we would do it with the Qt State Machine Framework, as you already know, in C++. You create a Qt State Machine instance, you create Qt State instances, you connect them by adding transitions, and each time one of these transitions triggers, it actually changes the label of the button. You can see that in the second paragraph with the assign property method calls. Finally, you'll add the states to the machine, set the initial state, and then start it. That's about it, not anything else. Now, with the declarative syntax we've added just recently, this can get a bit easier, and you can do it, that's the special thing, you can do it in QML. So you create a button instance, that's from Qt Greek controls, for example, and bind the text to the activeness of one of the states. So in this case, if S1 is active, you name the label S1. If S2 is active, you name it S2. And in the else case, you name it S3. Nothing else you need. And below that, you create the actual state machine in QML. You use a state machine node, assign initial state, say that it is running by default, and add the substates of this machine right away. So you say state, give it an ID, and also add transitions to it, and say where the transitions should go and which state they should activate. I hope that's clear so far. The types we've added in DSM are basically all inheriting from the nodes we have in the Qt State Machine Framework already. So there's QFinal state, you may know it, and for QML we've added final state, and same for QHistory state, there we have history state. The point is that all these components you can use in QML are actually QML ready, so you can use them to create those machines in QML. Yeah, some special features of DSM. You may know QState already has signals like exited or entered. And then it gets very easy in QML to actually react on these signals by just adding signal handlers as just normal in QML. So you say state on entered, colon, and then just do what you want. The same is for on exit, of course. For the signal transition, that's also a special method inheriting from QSignal transition. This one can use a guard and a signal condition to control when and if a transition should actually fire. So, for example, you state signal transition, say this should fire as soon as button clicked got emitted, but only if some other condition equals to or evals to true. So, but why did we create this? That's the question. QML DSM actually allows you to write hierarchical state machines in QML. Maybe you know the state component from Qt-Quick. That's not sufficient for that. The state component from Qt-Quick is just for a flat state machine, so you can't nest them. And this is mostly used only for animating stuff. You cannot use that to really describe complex state machines. Additionally, the declarative syntax allows us to do tooling. So we could write, for example, a graphical state machine editor, which basically where you can track together states and transitions, finalize it, and then export this QML code in the declarative manner. And additionally to that, because you have declarative syntax and you have the whole machine visible at once, you can actually run static analysis on the state machine as well. So you can check if there are some states which are not reachable and stuff like that, and that you can do that at compile time, actually. Another possibility is to generate C++ code out of QML DSM. So that's it about QML DSM. What are our future plans? So QML DSM itself is considered done already. We've actually the first commit we did was basically mostly done. So, and it's actually just a really small wrapper around the Qt state machine framework. So it's really not that much code, but it's just to be able to use that from within QML. The plans we have, mostly speaking with my KDAP hat on, is to provide a graphical state machine designer and debugger handling QML DSM. This is already in the works. We are working on it. And the read-only version, you can see that in the Gamma Ray demo at our booth. That's basically the debugger part of that thing we're developing. Okay, that's it already. Yes.